I'm here to share the latest improvements that we made with the new 6374 model. So as you can see, we have a full lineup now of 5 different OSAs. The 6374 is the latest version, and it complements our existing models that cover from just visible to telecom to longer wavelengths up to 2400 and 3400 nanometers. And it's the only OSA in the industry that covers both visible and optical communications wavelengths. So the key features I want to review is that this has, of course, the long wavelength range. It has a high wavelength resolution of about 50 picometer or 0.05 nanometers. Has a very respectable sensitivity of -80 dBm. Has outstanding filter characteristics, much faster throughput. Actually, the throughput is 40 times faster sweep speeds than the previous 6315 model, and it has actually 100 times faster data transfer rate than the old model because it's using a LAN communication port versus the older GPIB port. And another thing that's very exciting is it has 100 times greater number of sampling points. We have 100,000 data sampling points, which means that you can do a sweep of a very, very broad range with just one single sweep instead of making multiple sweeps with it. And the key things wanted to also point out is it has a new purging port feature. That means you can use it to measure signals and eliminate the water absorption from the signal by using either dry air or nitrogen into the purge port that's on the back. And this shows you the results of the signal before and after the purge, using the purge port to eliminate the water absorption lines. Another thing that's also new is it has an internal filter to eliminate the second order diffracted light from signal, your input signal of 760 nanometers in this case. You would normally see a second order light at 1520, whereas if you use the filter, it basically eliminates that second order diffracted light. It has an internal self-calibration port that has internal reference source to do the calibration. And it also has, of course, much more updated GUI user interface with the mouse-driven GUI, and you can use your mouse to control and select anything from the menu by clicking on the item, and it gives you a very convenient and intuitive pull-down menu for anything that you would see on the screen to change the resolution and sensitivity and any parameters you see on the screen, as well as a capability to zoom by just clicking on 2 points. So what we're showing here is a very broadband super continuum light source from NKT Photonics. We wanted to share that very broad spectrum and show the capabilities of the unit to be able to measure from visible all the way to the telecom wavelength range. What I'd like to do is also showcase our other OSA models here at the Photonics West. So we have here also the 6375B. This is a longer wavelength version, goes from 1200 to 2400 nanometers. So we're showcasing the fact that it also can measure the telecom wavelengths with a built-in WDM analysis routine. And over here next to it is an even longer wavelength version. This is our longest wavelength model that we also introduced very recently. Is the 6376 that goes from 1500 to 3400 nanometers. And this is showcasing a 3 micron DFB laser light source to show in a very narrow line width of this. So this is actually our most popular model. This is the AQ6370D. It's popular because it has a very versatile wavelength span from 600 to 1700 nanometers. So it covers the telecom wavelength signals for the 850 nanometer transceivers as well as the 1550 C-band devices. And next to it, we have a visible wavelength model that focuses mostly on the visible wavelength starting from 350 to 1200 nanometers. And this is very precise for high resolution measurements down in the visible wavelength. We can achieve as good as 10 picometer resolution in the 400 nanometer range.